So, good day sir, my name is Mark Masasako, and in this video we're going to talk about marine radars. So in task 1, what is a marine radar and how does it work? So a marine radar is an equipment that is perhaps used the most on the ship's bridge by the officer of the watch in carrying out a safe navigational watch. So the first picture below shows the inside view of the bridge. That is the closer look of the radar inside the bridge, and the second one, that object in a straight position, that thing is the outside view of the radar found above the bridge. So next, the term radar is an acronym for radio detection and ranging. The marine radar works on the basic principle of electromagnetic waves. The radar antenna sends the high-speed electromagnetic waves to establish the location, which is the distance, the velocity, and the direction wave traveled along with the altitude of the object, moving or stationary. So this is the marine radar cycle. So first, the object, uh, from the object, uh, it sends electromagnetic waves, and the antenna will receive it. And from the antenna, it will be going to the receiver, the radar screen, to the signal processor, to the master clock, to the modulator, to the transmitter, and to the duplexer. So duplexer, yeah, that's it. So that's the marine radar cycle. Next, uses of marine radar are the following. So it is used to calculate range and bearing of the target, and thereafter use the information to determine speed, course, and etc. Next is the integration with the other shipboard equipment such as ECDIS to derive precise data. Next, navigating on vessel and her course with regard to collision avoidance. Next is fixing the ship's position using terrestrial objects such as lighthouses, buoys, and etc. Next is the differentiating between targets in high traffic density areas. Next is the determination of the weather to an extent. Next is used by VTS in controlling coastal traffic. Next, usage of features such as parallel exceeding to ensure safe navigation. Next is the alleviating workload on the officer of the watch on the bridge. And lastly, used extensively in pilotage that covers the above aspects. So next, uh, the radar system out the radar system out electromagnetic waves as a high speed signal which will travel several times in the direction of radar facing. If there are no objects in the direction of the wave, the radar screen will show blank. If there is an object which will reflect on the wave back on to the radar, the computer will set up of the radar will determine the distance between the ship and the object along with its location. Hence, it can be said that the radar basically reads two things: the position of the object and the direction of the same. Next is the radiation hazards and the precautions. So, um, the the power that radar systems emits varies from a few milliwatts to many kilowatts. Large space tracking radars. So, however, a number of factors significantly reduce human exposure to RF generated by radar systems, often by a factor of at least 100. Radar systems send electromagnetic waves in pulses and not continuously. This makes the average power emitted much lower than the peak pulse power. Radars are directional, and the RF energy they generate is contained in beams that are very narrow and resemble the beam of a spotlight. RF levels away from the main beam fall off rapidly. In most cases, these levels are thousands of times lower than the main beam. So, many radars have antennas which are continuously relating or varying their elevation by a nodding motion, thus constantly changing the direction of the beam. eh, Areas where dangerous human exposure may occur are normally inaccessible to unauthorized personnel. So, next, main features and uses in marine radars in shipping industry. So here are the marine. So here are the main features. So first is the parabolic radar antenna. It transmits and receives electromagnetic waves as far as a target being displayed is concerned. That is basically the wave that bounces off a certain object that paints itself on the PPI or the plan position indicator. Next, the frequency and the time taken by the flashes to return reflections to the radar receiver of the ship helps to find out whether the route of the boat can be continued with or not. The transmission and receiving of the poles travels twice the distance in going and hitting the target and back. Therefore, the target displayed on the PPI is basically half with regard to its range. Next, on the PPI or the plant position indicator, the reflections can be seen so that identifying the factual distance of the objects can be even easier. The same paint on the PPI can be also be checked for the determination of the bearing of the target. So that ends the presentation. That would be all, sir, and thank you.